Algebra 2, Lesson 24, Fractional Equations and Overlapping Triangles. We're going to go backwards again. We're going to start with overlapping triangles because those are pretty quick. So if we turn the page and we go to practice C, we have to find x and y. I've reconstructed this triangle over here. And what we'll notice is that these two triangles are similar because they both share this common angle, and this angle is the same for both of them. So by angle, these two triangles are similar. Now what we need to be careful of is the lengths of our larger triangle. So we'll use proportions to solve this. We'll start with this side. Now this proportion isn't going to be 2 to 3. It's actually going to be 2 to 5. And the reason why is because the length of the size of the larger triangle is actually 3 plus 2, which means that it is a total length of 5. So we do the shorter to the larger, which is 2 to 5, and then we'll go ahead and relate that with the base of 4 to y. So that is equal to 4 to y. And then we cross multiply to solve. We get 2y equals 20 divided by 2, and y is equal to 10. So we've got one answer already. Y equals 10. Now, solving x is going to be difficult again because this larger triangle, this whole side is not only x, it is x plus 3. So when we set up our proportion, we'll start out over here with our 2 is to 5 as 3 is to x plus 3. So now we've got a polynomial in the denominator. So when we cross multiply, this 2 is going to have to distribute to every term in this polynomial. So the 2 times x plus 3 is going to come out to 2x plus 6 equals 15. And then this is just a simple equation to solve. We subtract 6 from each side. We get 9, 2x equals 9, or x equals 9 over 2. So y equals 10, x equals 9 over 2. That one's done. All right, now let's move on to fractional equations. On the same lesson set, we have two practice problems. We'll start with A. And with fractional equations, the goal is to find a common denominator amongst all terms, so that way we can eliminate the denominator. When we look at all of our denominators, we have 4, 3, and 4. The common denominator is going to be 12. So if we multiply each side of the equation, or well, each term in the equation by excuse me. If we multiply, hold on, pause. Sorry, I had to get a cup of water. My tongue was getting tied. Okay, so the least common multiple is 12. If we multiply each side of the equation by 12, that will give us a common denominator that we can just work out of the equation. So the way this works is when we multiply 12 times 4x plus 3, what we end up getting is 24x plus 36 over 4, and then when we multiply it by 4 over 3, we end up getting 48 over 3. And then on this side we get 12 over 4. That one's pretty simple. And what we see here is when we multiply by the least common multiple on each side is each one of these terms is divisible by their denominator, meaning they can be perfectly reduced into a whole number fraction. So here we see that 4 can go into 24 6 times, so that becomes 6x. 4 can go into 36 9 times, so that becomes 6x plus 9. Here 3 can go into 48, and it goes in, let's see here, 1 and 8, 6. It goes in 16 times. And then the last one, 4 can go into 12 3 times. So when we find the least common multiple of all of our denominators, we multiply each side of the equation by the least common multiple. So now that we're dealing with whole numbers, we can start combining and moving them. So 9 minus 16 is going to give us negative 7. So we have 6x minus 7 equals 3. We add 7 to each side. That will cancel, and then we get 6x equals 10. From there we divide by 6, and then x equals 10 over 6, which reduces to 5 over 3. And that is your final answer. Moving on to practice B. Why am I moving my paper? Ha. Okay. Now for practice B, I'm going to show you an alternate way to solve these problems, which is actually my preferred way. First off, with this equation, we'll see that this side has a whole number. First thing we're going to do is correct that whole number by turning it into a fraction and placing it over 1. So if you have a fractional equation, go ahead and turn everything into a fraction before you reverse it back to a whole number. Now the other method is, instead of finding out the least common multiple here between 3, 5, and 1 is 15, instead of multiplying all these numbers by 15, which can get a little confusing as you get to higher least common multiples, we can instead just use use a common denominator. The same thing we use to get common denominators when we add fractions. And the reason why we can get away with this, so instead of multiplying by 15, how about we turn 3 into 15 by multiplying it by 5? And the reason why we can get away with this is when we multiply by a value of 5 over 5, that's only equal to 1. Any number multiplied by 1 is itself. So we're not changing the equation at all. So this one we get multiplied by 5 over 5, this one gets multiplied by 3 over 3, and the only thing we have to multiply by 15 is 2, which is a lot easier than multiplying 7 by 15, 4 by 15, etc. So when we go ahead and finish this off, what we end up getting is 20x over 15 plus 21 minus 6x over 15, which equals 30 over 15. Now once we have the common denominator on all terms, we'll just multiply by the reciprocal of that, multiply by 15 over 1 on each side, and then all the common denominators go away. So then we're left with a simpler equation. We're left with 20x plus 21 minus 6x equals 30. Now you can use either one of these methods. You can either multiply by the least common multiple, which would be a really high number, or you can multiply by values of 1. The main goal here is to get the equation with no denominators. All right? So once we've got that, it's pretty simple to solve. We start combining like terms. 20x minus 6x gives us 14x plus 21 equals 30. Subtract 21 from each side. We get positive 9. And then 14x equals 9, divide by 14, x equals 9 over 14. And we're done.